Hello guys. Here we have another lesson plan. H. So the question for this is actually based on integral of x raised to the power of n multiplied by the logarithm of x to base e. And here is the question with dx. So at first we can easily use integration by part here. Please make sure that you use u to be equals to logarithm of x base e. Then from here, you can easily continue, and then you say dv will represent xn dx. So when you have this, I can easily differentiate such that du dx represent, when you differentiate logarithm of x to base e, this is very direct, that should be 1. Differentiate x itself 1 over repeat x back. And at the same time, remember that there will be a dx here, du dx, then multiply both sides. And here in this case, when I integrate both sides, integrate the v, I'll end up having v. So when you integrate x to the power of n, I'll have xn plus 1 over n plus 1, right? And then you go ahead and say, okay, x is to the power of n logarithm of x to base e dx is equals to uv minus integral of v du, using integration by parts, right? And then u itself is logarithm of x to base e, right? Then multiply by v. The v we got now is xn plus 1 over n plus 1, right? Then followed by negative sign. Then you integrate v xn plus 1 over n plus 1. Then du is 1 over x dx. Now from here, we can still proceed by saying we have xn plus 1. We have logarithm of x to base e all over n plus 1 minus, and then 1 over n plus 1 will come outside from the integral. We end up having an integral of xn plus 1 divided by x. You just make use of indices, and that should be x is power of n plus 1. When you have a division, then that will be negative of this power. So this is what I have left. So when you proceed, you end up having xn plus 1 and logarithm of x to base e over n plus 1 minus 1 over n plus 1, then integral of x plus 1 and minus 1 we cancel. Whatever I have left will be n, the power of n. So we can easily integrate this by saying we have xn plus 1 logarithm of x to base e over n plus 1 over n plus 1, and this gives x n plus 1. When you integrate xn, that will be xn plus 1 over n plus 1. Then we end up having, when you multiply this, you have n plus 1 square. So trivially, I notice that x raised to the power of n plus 1 over n plus 1 is common, not true. So whatever I have left is logarithm of x to base e. This cancel, then I will end up having negative of 1 over n plus 1. So this is what I end up having as the solution to xn logarithm of x to base e. So therefore, trivially, this result is that you leave it like this, or you end up having just this outside, factor out 1 over n plus 1, and whatever you have left to be x n plus 1 ln logarithm of x to base e over 1, right? Then minus xn plus 1. This goes, and 1 over n plus 1 cancel this, then whatever I have left is this. So this is how it works. So this is what we just have, and then this gives the final result. So thanks for watching. I really appreciate. Um, the next thing is, okay, lesson plan I, and that question is actually based on reduction formula for xn cos nx. For this question, is going to be a very very hard one to get, but to me, from my own point of view, the solution to this is a very complex one. Yeah, it's a very complex one. I would have preferred what if there's an error in the question, but the question should have come this way: xn then cos x. This is how the question should have come. So that's how it works. So this question should have come in this format, not nx. You have n, we also have na, so it's going to be very, very hard one to get. But if you want to get solution to this, then it exists. But this one is a very, very complex one. So I think that should be the exact question I'll actually touch for lesson plan I. So thank you.